Hey guys, thanks for joining me for the summary key for your forces continued notes. This is super important that you're running through this, making sure that you've got the details not only on paper essentially, but also your thinking, because as you have homework checks and quizzes, obviously these are going to be popping up. So just real quick, going to run through these first few. Just a definition of a force is a push or a pull on an object. And we, of course, are measuring that in newtons. And we can actually total up all the forces acting on an object by calculating the net force. And that is going to be done by looking at the direction the forces are going and coming up with a total. So we'll either add them or subtract them from each other, coming up with the total or the net force. And there's two categories of net force that we've been looking at. The first one here is a balanced net force. That essentially means the object is not in motion or moving at a constant rate. And when we think about acceleration, that's what's going on here with this zero. When the net force is zero, that means it's not speeding up, it's not slowing down, it's essentially staying the same. So when that net force is balanced or adds up to zero, that's what we know about the object's motion. In the other case where the net force is anything but zero, then we call that unbalanced. And so that clues us in that the object is in fact in motion. So remember, when we get a net force that's unbalanced, we get a value, let's just say 3, and that's of course measured in newtons, and then we also get a direction. So left, right, up, or down, and that is determined by the arrows that show up on that diagram. So here was a few. If you watched that first video, I kind of got you started on a few of these, so I'm just going to finish them up. Here we have two forces, one up, 1200 newtons, and one down, 800 newtons. I am simply subtracting them because they're going in opposite direction to give a total of 400 newtons. Check that you have that unit there. And I'm looking at the bigger arrow to know the direction. In this case, it's moving up. And another clue I have here is this tension force. That's an object hanging. So this might be something being pulled up from a pulley or lifted, maybe like a birdhouse being hung, something like that. So that would be unbalanced because I ended up with a number other than 0. Here I've got 600 going up, 800 going down. So biggest minus smallest gives me a net force of 200 newtons. And in the direction, again, I'm looking for the bigger arrow, is going to be down. And again, another clue I have is looking at the forces. Gravity is always my downward force, but here I have air resistance, so that clues me in the object is falling. And because it's falling, that means the air molecules are hitting it going in the upward direction. So overall, this is moving downward, an unbalanced example. Here I've got two directional forces. I've got vertical and horizontal. I'm going to start with the two up and downs because when I look at those, I've got gravity pulling downward and normal, meaning whatever this is sitting on a surface and that surface is pushing back the equal amount that gravity's pulling down. So when I look at those two and I show my work, my calculation here is in the up and down direction, there's no motion. That's a 0. So then I move to my two horizontals, my left and right. Again, biggest minus smallest ends up being 60 newtons. Again, unbalanced because it's a number other than 0. And the direction it's moving would be of the larger, that would be to the right. Okay, so when you end up with 4, just pick 2 to start with. 2 are typically going to cancel out, so you're just seeing that one directional movement there. Here I'm asking you to put the name on some different forces. So I already gave you the clue in the beginning video about gravity. We know that's our downward force. Gave you a clue about the scenario. It's a textbook being pushed across a desk, right? So here's the textbook. I know gravity is pulling down. The force opposite of that is going to be coming as a support force from the desk. That, of course, has to be normal force. You are pushing it, and the directions say pushing it to the right. So again, a big clue here that that's the larger arrow. And so the force from your push is going to be the applied force from your hand. And as you're pushing it to the right, there's a force happening right here between the desk and the book, opposing that movement to the right. So the book and the desk are rubbing against each other, trying to slow the movement of the book down. That is going to be the friction force. And looking at the arrows, we can see a little bit about their values based on their size. There's no numbers here. I'm not asking you to calculate, but just noticing this is the larger one, so that clues me in about the motion of the book as well. So kind of thinking about that for this question, would this be considered balanced or unbalanced, and why? Well, I know the book is in motion, and so that's my biggest clue. Because there is motion, this is going to be an unbalanced force. All right, a few more calculations here. This time I gave you the net force. You were simply looking for the missing. And okay, let's start here. So we were looking at big minus small, knowing that the direction was to the left. So that has to be my bigger. If I erase this here, we can be reminded this was the bigger of the two arrows. So I'm just going to give myself that visual, big and small. And those have to equal 8. So when I have my biggest number minus my mystery number, I know that's going to equal 8. So of course I'm looking for the answer of 5 newtons right here. Same thing, looking at the arrows, I can see this is the bigger force, this is the smaller force. Notice it says show your work a bunch of times. That's super helpful, especially when you get stuck and you want to screenshot something to your teacher. They can really see what your thinking was prior to your getting stuck. So big minus small, I've got 25 minus this mystery number is going to give me a total or a net force of 15. So that mystery number is going to be 10 newtons. Here again, I've got 4. I've got the vertical and I've got the horizontal. I know this object is moving to the right. So I know that's going to be my overall biggest. It's not moving up or down. So when I think about these two, I know there's no up or down motion. So that means my net force here has to be 0. So when I subtract these two, I've got to get to 0. That leaves this as a 50. And when I'm solving over here for my right arrow, which is the bigger of the two, I've got to figure out what number minus 22 is going to give me 13. So when I add those back together, this is going to be, oops, here it is, 35 newtons to calculate that out. Thinking about all these problems, number 7 is related. What can be observed about the diagrams in number 6 to confirm the direction the object is moving? So observed on the diagram, what we could look at is the size of the arrows, and the largest arrow, or the longest arrow, I guess, equals the direction. Couple left, here we go. Diagram to the right, so over here, shows the force acting on the box, being pushed across the floor. Calculate the missing. So again, we're kind of looking at the pairs. And notice here the net force is 0. So even though the box is moving, its net force is 0. That gives me a clue it's moving at a constant speed or a constant rate. So when I've got my first two here, I've got 200 minus a mystery number's got to be 0. Well, of course, B is going to equal 200 to even that out, newtons. And then over here, I've got the same thing. 50, again, minus mystery number gets me 0. So A has got to comply with that net force of 0 as well. Last couple are about acceleration. I gave you a little preview of these in the review video. Acceleration of a car going around a corner at 200 miles an hour. Remember, acceleration is looking at a change in speed, either increase or decrease, or a change in direction, turning a corner. So while the speed is saying consistent, the car is going around the corner. So yes, this is definitely going to be acceleration. And we wanted to use the words speed and direction in the because. So we could say something about because there is a change in direction. Right? It only has to be one of those things changing. So even though the speed is not changing, still considered acceleration. Here I've got airplane at a constant speed of 500 miles an hour in a straight line. So I'm looking at both factors, speed, unchanging, direction, unchanging. This is going to be a no. No acceleration because no change in speed, no change in direction. Make sure you got those keywords in there, speed and direction, in your explanation. And finally here, the football being thrown. So it's starting out at one player, going from motionless to motion, rising up, sinking back down, and again, motionless in the arms of the receiver. So I'm seeing a change in really all of those things. It's speeding up and slowing down. It's changing its direction as it arcs up and goes back down to the other player. So yes, acceleration. And again, you can decide which one you want to highlight in your explanation to why this is in fact acceleration. Again, if you are feeling stuck on one of these, despite the detail that we went over it with today, please take a screenshot, reach out to your teacher, and just let them know, hey, here's where I got to, or I didn't understand where this number that Ms. Chumley talked about came from. Let us know how we can help you so we can